This is a question from the 2020 EC GATE paper. This is question 20. It's a digital to analog converter or DAC question, which asks us to find the output voltage of a 10-bit DAC, which has a range of 0 to 10 volt for a given hex input pattern 13A. Below the question, you will find the title of the NPTEL course or video that is relevant to this topic. So before proceeding to solve the problem, let's look up a little bit of background. So an digital to analog converter is one that accepts an input X, which is binary, right? It accepts an input X, which is binary, and outputs a voltage V of X between ranges V1 to V2, which in this problem are 0 and 10 volts respectively. And the input X is a 10-bit value. So if a 10-bit value goes, if you have a 10-bit value, it goes from 0, 0, 10 bits to 1, 1, 10 bits, which corresponds to 0 in decimal and 2 power 10 minus 1. So 0, 1, so far till 2 power 10 minus 1, right? And the idea is that each value of the input voltage will correspond to the input X will correspond to an output voltage V in linear steps according to linear steps of equal size. So this is the lowest value of the output voltage, which is 0 for us, 0, and 2 power 10 will correspond to the highest value of the output voltage, which is 10 volts, right? So the output of the DAC will go like that. So it's fairly easy to see then that the formula is for the output voltage of the DAC is this. Why? Because if you were to substitute in the numerator of that formula the value of all ones for the inputs Bi, that is B9, B8, which is the input bits of X, if you were to substitute all ones, then you will see that the numerator evaluates to 2 power 10 minus 1, denominator is obviously 2 power 10 minus 1, right? And this is equal to 10 volts. And of course, if you were to substitute 0 in for all the Bi's, then the numerator is 0, and so therefore it's 0. Thus we get the range properly. So that was the background required. Now moving on to the solution, you can see that given the formula, it's extremely straightforward now. The output is 13AH, so this is A, which is 10. This is 3. I'm grouping 4 bits at once because it's a hex value, right? It's given in hex. So that's a 3. And that's a 1. It's supposed to be 4 bits, but it's truncated on the two MSB sides. And yeah, given this, you can see that the 1, the bit position for 3, 4, 5, and 8 are 1, which correspond to, if you were to substitute that in the formula, having the powers of 2 of those locations be present in the numerator, which is 314 by 1023, which is approximately 3.0624, 3.0694. And so the correct answer is 3.069 rounded off to 3 decimal places.